Hello everyone. So in this video, we will be discussing about content-based filtering, which is one of the techniques for doing recommender systems. So what is content-based filtering? The intuition is that we recommend items similar to previous items that user like. So for example, we recommend a movie based on the genres and or actors. For example, I like action movies. The system will recommend me to watch Avengers because it's an action movie. What else? So we want to recommend a restaurant based on location. I am in BGC, and the system will recommend me restaurants within the area. Those are content-based filtering examples. And the steps for doing content-based filtering are as follows. We first build the item profile matrix, and then we compute the user profile based on that matrix. Then finally, we retrieve items in profile matrix that are most similar to the user profile. So let's start with this example. Say, for example, we have different movies here. So Inception, Memento, Avengers, and The Matrix. Again, I have used those movies because I'm into dark shows and action ones. So here are the features for those, or these are the genres in this example. So we're only focusing on the genre feature in this example, but this could be any other set of features for different problems. So for Inception, it's dark action sci-fi thriller, so that's why you're seeing one here. For Memento, it's dark action and thriller, not a sci-fi one. So it's blank here. For Avengers, it's action and sci-fi. For The Matrix, it's dark action sci-fi, not thriller. So this will be our utility matrix. Now let's build the user profile based on that matrix. So for example, suppose user X has watched Inception and Memento, and we just assume that the user likes those because the user watched those. We simply get the average of the values there. So because I have 1 and 1 for dark, then that will be 1. Fraction will be 1 because 4 are 1. For sci-fi, it's 1 and blank, so it's 0.5. And for thriller, it's 1. Now this will be our user profile. The next step is to retrieve the most similar items. So these are the movies that the user has not seen yet. So the Avengers and The Matrix. And these are the genres for those. Now we calculate the similarity or distance measurement. And for this one, we will be using cosine similarity. And with that, we can now retrieve the most similar items. For cosine similarity, the higher it is, the better. So remember, this is our user profile, 1, 1, 0.5, and 1. We calculate the distance of our user profile with the items or movies that the user have not seen yet. And these will be the scores. For Inception, you have 0.97, Memento 0.96, but then again, you've already watched those. So we will be recommending the movies that the user have not seen yet. In this case, you have Avengers and The Matrix. For Avengers, you have 0.59, The Matrix is 0.8. This is the next best item that we have, so we recommend this. What if we have ratings instead? Instead of just assuming that the user likes something because the user watched that, we now are using proper ratings instead. So for example, if the user rated 5 and 4 for Inception and Memento, what we do is we just multiply those numbers with the initial matrix that we have. So it will now be 5 for Inception and then 4 for Memento. And then we get the average, similar to the previous one. So it's still the same, but we basically have just added that multiplication of the user's ratings. Now we will end up with this user profile, 4.5, 4.5, 5, and 4.5 for those 4 genres. And we will now be calculating the distance of this user profile with the rest of the movies. And if we use cosine similarity, we will end up with the following values. It's 1 for Inception, 0.84 for Memento. Again, we already watched those, so we will be recommending something that the user has not seen. In this case, it's still the Matrix, still the best item that we have. So that's the average rating variation, right? But there's a mean centering variation. So assume same everything, but now we will apply mean centering. So same that we have 5 for Inception and 4 for Memento. But we subtract the mean. Now we will end up with 0.5 and negative 0.5. We will now multiply that with the original matrix. So 0.5, negative 0.5, and so on and so forth. And then we get the average of those. So it will be 0, 0, 0.50. And our user profile will now be 0, 0, 0.50, and then we calculate distance or similarity of the user profile with the rest of the matrix. So in this case, if we use the mean centering variation, we will choose Avengers because it has a higher cosine similarity. It's 0.71 versus 0.58. So there's a caveat here. We only have ratings for 2 movies and both are highly rated. This would return more meaningful results if we have more samples, including a few which are rated low. So what are pros and cons of content-based filtering? First is for the pros, there's no cold start or sparsity problems. Next is no need for data on other users. And then no first rater problem. We're able to recommend unpopular items. And this is very explainable. Explainability by simply listing the content and features. Cons would be following. Finding appropriate features is hard. Getting the user profile for a new user. Over specialization, it never recommends items outside user's content profile. So again, we typically use this when we're still building up our recommender system because we still don't have the ratings, we still don't have many users and items in there. So we first use content-based filtering, and once we have more, we transition to the other technique, which is the collaborative filtering techniques. That's it.